So, very good morning again to all of you. So, I'm going to take the first session where I'll be introducing the data analytics domain, and I'll be discussing one application that is known as market basket analysis. Okay. So, just let me configure my tab. Okay. The first of all, we'll be talking about that what is actually data analytics. Okay, as you know that this data analytics is not new. Uh, I think since in 90s and 2000 and now, if you look on the present era, then we are working on this. Before we call it something like a data mining as well, which is actually nothing but it's a data analysis part. So there are so many synonyms actually is for data analytics. So we'll be talking about what actually the why data actually analysis or data mining is required. What is actually we mean with if we talk about data mining, then on what kinds of data we do, what sort of functionality is available in data analysis, and then the interestingness of the patterns is very important. Then classification of data mining, issues involved, and then we'll go for market basket analysis. Okay, so this will be the flow of our talk. If you look on the technology evolution, then you'll find that in 60s we have started with data collection or some sort of elementary early database creations. We have something like IMS and network databases, which was in place. When after 10 years of the of this particular initial evolutions, we move to one of the reversionary data model, which is known as relational data model. And still it is important because we are still using this relational data model. Okay. Obviously, some sort of implementation, sort of, you can say some environment creation for all these relational model database manipulations, executions, we have created it. Then when we move to 80s and all, then we actually went for this relational database, then advanced data models like extended relational, object oriented, deductive, and so many others like spatial and engineering databases. Okay, so that was the era where actually we worked on such applications, because I think if some of you might remember that or might be aware of that during that phase people were using, like, all scientific you can say programming was done or database creation was done. We have application and programs like COBOL. Then we have some sort of scientific programming as Fortran. So that was the stage where actually this is the phase where actually these were very much popular and useful. Okay, and then we move to some other high level languages like C++, and uh, Java and others. Then we have something like Oracle, DB2, and so on. So MySQL, SQL Server. So all these actually came in picture in early 90s and after 80s. Okay. Then after like you can see that during the 10 years between 90s and 2000, there was evolution comes, which actually talks about what we call it as data analysis. Okay. So data mining and warehousing, multimedia databases, web databases, because this is the era where actually we have started this internet and all. And after 2000, this internet becomes, you can say, necessity of every common people. So this is the era where actually you can say that from 90s to till date is actually we are doing lot of activity, or you can say the entire analysis or decision making is based on this mining, warehouse, big data and all. Okay. If you look on the historical preview, then this analysis and warehouse was actually introduced in early 90s itself, but the entire community was not sure about the acceptance, so it was almost delayed for 10 years, you can say. And then when actually the environment was created in a way where actually we are dealing with the huge amount of data, then it was thought of that, okay, we need this warehouse essentially. And since we are talking about some warehouse storage of the data, then we thought of that if we are storing such a huge amount of data, then why not we should go for analysis of such data also. So altogether, like when this particular actually relation was actually placed in the environment, then it was thought of, okay, we should work in this direction also, and people have started it. And I think in today's era, we call it as this is a data analysis era where actually we are 100% working in this particular field. Traditionally, if you define, it talks about extraction of interesting information or patterns, okay, from a large databases. Okay, so this could be databases or this could be warehouse as well. Okay, so it could be anything. And now it is added big data also. Okay, so what we look is that either we are dealing with the databases, maybe small or large databases. Either we deal with the data warehouse, or we are dealing with big data where actually data may be static or streaming data, which is real time maybe. Okay. So it could be anything. So what we look for is we look for some new information and patterns which could be actually useful for having decision making. Okay, so this was the case, and this is the case in today's analysis. Okay, so we call it as knowledge extraction, then we call it some data pattern analysis as well. Sometimes we call it as data archaeology. Even you can call information harvesting. Uh, Even in management terms, we call it as business intelligence. So there are so many synonyms available for this. So all actually talks about data analysis. Okay. Wide range of applications. In today's world, you name any application, you will find that this particular analysis is a part of that particular environment. Whether it is you are talking about market or customer or sales, even you talk about stock forecasting or a weather forecasting. You talk about some text analysis, what we call it as text mining as well, or you could talk about web server data analysis. So a lot of analysis you can do, or intelligent querying processing. What we are experiencing these days is some online exams, some online applications of course conductions. All these are actually based on this particular domain itself. Okay. Altogether, if you look for what are the steps involved in particular KDD process. We call it as knowledge discovery databases or knowledge discovery process. So you can see that this part is actually talking about a data warehouse. Then we perform some selections. We get the task relevant data. Then we apply the algorithms. Okay. This is where you apply, you can apply any algorithm which is related to analysis, or you can say data analysis. You can apply ML, deep learning, you can apply any statistical methods, you can apply any sort of tools which actually gives you some pattern as a result. Okay, so this is where actually you deal with all these, whether it is data analysis, machine learning, deep learning, statistical analysis, tools which actually gives you patterns and interesting novel informations. So all these actually could be done at this stage. And obviously, when you generate this pattern, out of these pattern, some of the patterns you declare as knowledge. So all this is what the steps involved for this particular data analysis part. Let us come to this particular warehouse part. Just let me just erase this. Okay. This is the part where actually you can replace with any database. You can replace with big data. You can replace with streaming data. So that means this is where your data could be anything. It could be warehouse. It could be any simple databases to any different databases available to you. It could be anything which is big data and all, streaming data and all. The moment I say big data, streaming data and all, then we talk about something which is distributed and parallel. Okay. That means it is not necessary that we are dealing with a one sort of system where actually the data is stored, rather than we are dealing with a set of systems where actually multiple terminals, multiple systems are there. Okay. So you can say that there are multiple systems where you can partition the data, and individual system can process your data as per your requirement. So that could be one configuration for big data processing. That could be one configuration for stream data processing. Then you make use of MapReduce, Spark, or any sort of applications. You may use SQL for querying. You may use Spark SQL. You may use NoSQL also as well. So here is the place where actually we deal with the query language. Okay. So it can be SQL, it can be NoSQL, it can be MySQL, it can be Java, or so any applications, any languages which could provide you all construct which is responsible for getting this task relevant data, that could be used here. So that is what we have. So that means this is the place where actually different databases are involved. This is the place where query languages are involved. This is the place where actually you get the data which is required for the pattern generation. So that is why we call it as task relevant data. And task relevant data is actually gathered through a complex queries. Okay. These complex queries are generated over, it can be SQL, NoSQL, or say MySQL, or any languages which you are comfortable with or the environment is comfortable with, that can be used. Okay. And that can generate this. Now, since I think it is very clear that what are the steps involved in any analysis domain, now I'll just give you some idea that how this warehouse actually is actually coming in place. Some of you might be aware of this warehouse part. Let me tell, uh, I think maybe some of you might not be aware of. So I'm just talking about some warehouse concepts. The warehouse concept says the data must be historical. Okay. So it should be non-volatile, time variant, and the utmost part is it should be subject oriented. Okay. Uh, that means warehouse always is actually designed over subjects. So suppose I think most of you are faculty members or research scholars. So you have your institute. Okay? Certainly within the institute you have database applications like library information system. You have some sort of exam system. So all these are database where actually you are dealing with the data of students, teachers, and the other component of the institute. So all these two data, if I take this particular two data for right now, then what is happening for this is that these two databases are actually created on applications. Okay, though student and teachers are the main, you can say, contributor in this, but still dominant part is application. Application is the library info system deals with the application as that how to borrow and how to manage the book issuing within the library. Okay, so the entire database creation will revolve around this particular application. Okay, if we talk about exams, then obviously the entire database creation will always revolve around exams. But the moment I move to subject, and if I say that a student is my subject, the moment I say this, then whole set of concentration will revolve around students rather than applications like library or exam. What does it mean is that certainly I'm not interested to store the data of students in warehouse, which talks about that what sort of big books he has issued from the library, on which date, what was the fine imposed if not returned within due date and all. Those are actually day-to-day manipulation activity within the library. So that might not tell me anything about the students. So I'm only interested to take some data from library which talks about that what was the interest areas of the students. So that could be one sort of data which I like to store in the warehouse. Rather than day-to-day activity, I don't want to store it. So that part is referred that you just oriented with the subject only. And if my student is my subject, so I am interested to store all the information which tells me some features of the student. Okay, so that is what we call it as subject oriented. Historical in the sense that if I'm talking about warehouse, suppose I'm talking about IIIT warehouse, then certainly I may be interested to have last 20 years data. So obviously already students have joined, gone after completion of the course. So all data is already happened, stored and fixed. So that is why, and I'm dealing with that data. So that is why we call it as historical in nature. Non-volatile means once it is written, no changes is allowed. So it is almost read-only data, and it should not, you cannot go for deletion of such data. Okay, because this is actually talks about your history. Time variant, that means obviously the data is, since large span of time is involved, If I'm talking about 20 years data, then certainly we always look for data to be stored with time frame. Like, you know that maybe the first 5 years, like suppose if 1999 it was started, so up to 2005 there was some sort of same pattern of data is available. Whereas after 25, maybe 5 years, next 5 years up to 2010, another set of data with another set of informations, because there was change in subjects, there was change in curriculum, there was change in exam pattern, there was change in, so many changes actually happened over the time. So we actually would like to you can say store those informations as well. So we actually stored informations with that, with respect to the time also. So that is why we call it. So that is what we call it this. Now the issue with this is that if we the issue with warehouse creation is, since I'm talking about that I'm looking for 20 years of triple ITA data, then obviously with few years data might be stored in some other applications, few years data might be stored in some other applications, few years data might be stored in some other applications, and there could be a possibility that these data is actually stored in different formats. Maybe somewhere some data is missing also. So lot of cleaning is required. Then obviously cleaning also talks about not only the cleaning of unnecessary data, but also how to deal with the missing values, how to deal with the format transformations. Okay. When I'm talking about format transformations, I can say that if you talk about date of birth of the students or employees of the triple ITA, then there could be a possibility that the format which was stored in this particular data is different from this and this. So when you talk about integration of such data, that means I just want to integrate all these 20 years data into one place, then certainly this format may create problem for us. So in that case, what we'll do is we'll actually make a uniform formatting of the DOB. So that requires some sort of manipulations, that requires some sort of maybe mathematical manipulation or some sort of statistical formula might be used. In this case, only date formats uniformity is required to be done. In some other cases, we're actually filling up missing values, dealing with the normalization of the data and all. So you require some normalization formula, you require some sort of transformation formula, like it may be Wavelet or Fourier or something you may be used. So you may be using some statistical forecasting also to have some missing values to be introduced in the data. You may use some interpolations as well. So like all the tools are available, all the mathematics is available. Only the thing is, based on your requirement, you have or you have to decide that what need to be done so that I can get a very clean and perfect data for my analysis. Okay. So it is not easy because this should not be done manually. So that is why we actually make use of some sort of interface programs which actually can interact with these heterogeneous data storage. It may be like few may be uniform, but few may be heterogeneous in nature. So you have to deal with heterogeneity as well. So that means you need to write some sort of, you can say, APIs, which actually enables you to interact with all these heterogeneous storage of the data. So that need to be done. And let me tell you that normally when we integrate such huge data, which talks about the span of 10 years to 50 years or maybe more. So depending upon the span of time, you may require 6 months to 2 years for creation of warehouse itself. And that is why the warehouse creation is not implemented by smaller companies, because these such huge data integration is only done by some big companies or prominent companies which deals with data analysis in a very significant manner. Okay, so that is what we do it. So if any doubt in this, please you can ask me. Otherwise, I'll move forward. Okay, so I'm moving forward. Then if you look on this, then as I told you that these are the steps which you can see that creating target data set, data selections, as I told you, data cleaning and pre-processing. You can see that the most of the time or most of your time, like if you're looking for 1 year of sort of time frame for your particular pattern generations and all for a particular set of data, then most of the time will be devoted to pre-processing and cleaning part. Because if once the data is cleaned and pre-processed properly, then certainly your entire works become easy. We do some data reduction and transformations, as I told you already. These are the functions which actually we look for to be implemented on data. It may be summarization, classification, regression, associations, and clustering. Certainly we'll be knowing all these. The very important that choosing sort of mining algorithms, because these are hundreds on thousands are available for you, and out of that you have to choose which one is good for you, and that is actually the major issue in the any sort of analysis. Okay, this is again important, that pattern of interest, because what you look for is that your pattern should be simple, it should have some utility, it should have some durability as well, and obviously at most what we look for is novelty. So once you confirm all these, then you can say that okay, your pattern is interesting, that it should be simple to understand, utility must be high. Sometimes your knowledge may be novel, but utility might not be good enough, so then only you can reject. All, like, it should be simple, novel, utility must be high, all these should be there, otherwise we say that okay, we can ignore the patterns. Okay, so very few patterns will be actually selected for as interesting patterns and can be forwarded to the higher authority or higher, you can say, management for decision making. So that could be done. So before forwarding to the higher management, you look for visualizations and all. So that is very important, because visualization actually gives you provides you ease to understand the pattern. Okay, so that is again a very specific domain, and people are working very you can say actively in this particular domain as well, which is known as visualizations. We, like, lot of tools are available these days, like you have Python, where actually some special libraries are is actually available for these visualizations. I think, if I remember, that is referred as Matplotlib library. You have some tools like Tableau, which is very effective for visualization of the data, which actually deals with a multi-dimensional view of the data as well. So that sort of things you could do. And obviously the best part is that whatever you have discovered, knowledge you are talking about, it should be used. That means it must be the part of decision making. That is the goal of entire thing. Okay, so once you do that, your analysis, the goal of the analysis is established. Okay, just we are trying to relate with what we call it as data mining and business intelligence. You can see where like some of you might be you can say fitting into this, some of you might be fitting into this, some of you might be fitting into this, and some of you might be fitting into this. This is basically depending upon what you possess as skill set. Okay, so this part is actually dealt with this database administrator, we call it DBA. The next part, which is talking about data explorations and data mining, this is done by data analyst. So it could be any software engineer or person from computer science background or mathematical background. So that can act as data analyst. Normally, these are skilled persons. This is what we have is business analyst. These are, you can say, middle management persons involved. You can say it could be a computer graduate or it could be a management graduate. So this act as a business analyst, having skill set of all visualization techniques and all, which actually present the data in a particular simple form and understanding form to the decision maker, which is the end user of this. So you can see that data analysis involve all the sections of any industry or institute, which actually deals with the different part of the implementation of the data analysis. Okay. Architecture, if you look, it is very simple architecture. So you have databases, you have data warehouse, you can always add big data in this also. And then you actually access the relevant information, you access your, actually extract the task relevant data, and then it goes to database engine, data mining engine, and then we look for pattern evaluations. This is the knowledge base, which is actually nothing but it's a metadata. This is actually created for futuristic use or for optimization purpose. Okay, lot of optimization is required to be done in this case also. So it's very typical architecture and very simple architecture. The question is on what kind of data you can actually do analysis. The answer is you can actually do analysis on all type of data which you can have. So whether it is relational or a warehouse or transactional data, I'll be talking about this transactional data because this is actually related with market basket analysis. So I'll be talking about in detail about this transactional databases. So there are some information repositories or advanced databases like object-oriented or relational, spatial, which talks about data which is related to spatial properties. Then we have time series data. For example, you are talking about stock data and all. We have text databases. We have multimedia databases. Like in today's world, you talk about many image and video processing data. All these are multimedia data. Heterogeneous databases are all used because you can see that when you talk about IoT environment, you are actually involved with heterogeneous databases. And then the huge amount of data you talk about, that is what we call it as wide waveform. Okay. Okay. So hello. Okay. So different functionalities of data analysis, if you look, then you have actually what we call it as characterizations and discriminations as well. We have associations where actually we do correlation and causality analysis, where actually we do some sort of association rule mining, which I'm going to talk next. Then we have classification, predictions, then clustering analysis, where actually these two are almost talking about the same set of processing, but only the thing is both deals with the two different types of data. Like classification and prediction deals with the supervised learning, whereas clustering deals with the unsupervised learning. Okay, so these two are there. Unsupervised and supervised deals with the data, say where actually the classes are known, whereas in case of clustering D, this classes is not known. Okay, so if data is having classes, then you can go for supervised learning, whereas data is not having the class labels, you can go for unsupervised learning. So that is what the difference is. You have some trend and evolution analysis as well, where actually we do some regression analysis, situation pattern mining, then some similarity based analysis. So a lot of things you could do. Okay. Apart from this, I think you know that the category of data analysis we do is referred as something like what we call it as descriptive data analysis. Then we have predictive data analysis, and now we are actually going for prescriptive data analysis. So, and in today's era, we are a lot talking about prescriptive data analysis. I think in some lectures it will be covered. Descriptive, you know that what you are having is that all data analysis is performed on, you can say, some sort of historical data. So you take the reference of historical data and you actually process the current data for analysis. So that is what we're descriptive and all. Whereas predictive is actually, again, certainly we'll be talking about historical data, but what you are doing is you are actually predicting for the future as well. So future prediction is involved in this predictive analysis. Okay. So there is a minor difference between descriptive and predictive, whereas prescriptive analysis says that again the historical data is used, but when you talk about that, okay, there are a lot of actions you can suggest in case of predictive prescriptive analysis. So it says that you have to have this what and obviously when, and you have to answer this why also. That means if I say that I have done some analysis and I'm talking about some set of actions, so these are what are the actions. So we can actually suggest based on analysis that what are actions to be taken for a particular situation. Then always the analysis should also tell me that when to take these actions, and also you have to answer this that why should I go for this. So if you answer all these three questions for a particular data analysis part, then we actually, what you are talking about is prescriptive, because you know that in doctor prescriptions what you have is doctor actually goes through all historical you can say data of a patient, then it talks about the current data of the patient also, and then it talks about various actions, and it also tells that why I am taking these actions. So basically when we do same sort of activity in case of data analysis, we call it as prescriptive data analysis. Okay, so we deal with these three types of data analysis. Moving forward, as you know that if I talk about data analysis then or data mining, then it is actually a confluence of multiple disciplines, whether it is database, statistics, visualizations. Tell me any disciplines which is not part of data mining. Nowadays, people are from chemical engineering, people are from mechanical, electronics, you name any field, production, all these fields nowadays are working on data analysis part. So I think if you go through the papers, you'll find that there are so many applications of machine learning could be found in these areas as well. Obviously, information science could be a significant part of this, machine learning and all. So all these, so you actually it is confluence of all disciplines, you can say. Okay. If you look for issues involved, obviously when we talk about the data, so I told you that all type of data you can perform your analysis. When you talk about what analysis you can do all these. Then obviously techniques you are free to use. You can use database oriented, data warehouse oriented, machine learning, statistics and all applications. As I told you, almost all in today's world, almost all the discipline are having this particular data analysis application. Okay. Issues always be there. Issues like you can say that interactive mining of knowledge at multiple levels of abstractions. Okay, because if user will not be provided with abstractions, it will be very difficult to implement all the parts of the data analysis. So we have come up with some framework where actually we have hidden the details of the various components and various steps, and users are just to have the summation of the data and what they are looking for, what sort of analysis they are looking for. Just mentioning that part, the rest of the parts will be handled by the framework itself. Okay. It is very important to incorporate the background knowledge, because in absence of this background knowledge, analysis may be deviated as well. Okay. Choosing data mining query language or ad hoc data mining languages, I think you are free to choose any applications or any sort of languages. The provided that that particular language or application should provide all constructs which could be useful for analysis. Okay. So you are like expression, visualization, then handling noise and incomplete data. Pattern evaluation is actually the interestingness problems which I already discussed. Yes, these two are very important. That is efficiency and scalability. When you talk about any analysis, we always look for accuracy. Obviously, accuracy may vary depending upon domain and environment. So we should not expect 100% accuracy in all domain, because the data, you can say the type of data is varying across the domain. The pre-processing and noise-free data is not possible in almost all type of domain. So certainly the efficiency may vary depending upon domain or environment you are looking for. The other part which is need to be figured out is scalability, because scalability actually talks about that if I'm comfortable with the analysis of a certain size of data or certain set of algorithms, could it be possible to extend my data analysis in terms of size, in terms of algorithm? So that scale up is actually the issue, and always we look for that the algorithm must be a scalable size. As far as size of the data is concerned, we always look for more data to come, and we always look for need to be analyzed with the existing framework as well. Okay. Parallel, distributed and incremental data mining. This is very much important, because these are the components of big data analysis. And like framework like MapReduce, Hadoop framework, or you are talking about framework like Spark, or any distributed computing framework where actually you look for parallel and distributed computing, all these will be the part of that. And obviously we are very much concerned about the performance and scalability of such framework. Okay. Obviously, issues might come in terms of diversity of data types also. So you are actually going to handle some relational and complex types of data. You are going to handle with this heterogeneous databases and global information systems like World Wide Web, which is which can actually gives you the flavor of unstructured, semi-structured, and structured as well. So it is a mixed type of data you will be experiencing in this case. So obviously applications like you could look for is domain specific or intelligent query processing, or there may be process control and decision making could be part of that. The ultimate thing which these days we are concerned is actually the data security and the integrity of the data and privacy of the data. So I think talking about social network, talking about any streaming data these days, talking about IoT data, which talks about smart homes or smart offices. So all these actually deal with or is having the issues of privacy and all. So people are working on it, and certainly we'll be having one lecture session for data anonymity, which will be dealt with these issues. So that is what we talk about. So if I summarize, that means data analysis is one paradigm where actually we look for analysis of the data, depending and it could be data could be from any stream. It may come, like it could be from databases, warehouse, could be from any advanced databases, it could be from any unstructured or structured as well. So we have to deal with all type of data. Suddenly we go for pre-processing and all, and the integration of the data. Then we'll go for extraction of task relevant data, which you could do with a complex query executions. And then you can always go for choosing, instead of choosing one algorithms, you can choose multiple algorithms. You can execute those multiple algorithms on your data, and you can compare the accuracy and efficiency of those algorithms, and you can conclude that, okay, fine, out of 3 or 4 algorithms, one is good, best working for my domain, and the results can be forwarded to the decision making as well. Certainly in the meantime, you have to handle the data security and privacy part as well. So all these are components of the data analysis across all domain. As I told you that now in today's world, we are dealing with data analysis in almost all the domain, talking about bioinformatics, biotechnology, mechanical, chemical, all these fields, which is actually not by name, it is not, you can say people are not thinking of application of such thing. Still, people are using it. Okay, so it's a wide range of applications available for data analysis. So I'm just moving to this market basket analysis part. This is one applications of data analysis, what we call it as market basket analysis. I think people from computer science background might be aware of this particular domain. I'm interested. This is very interesting because this analysis is actually related to every common people. Okay, the why I am saying that this is related to every common people. The reason is that the ultimate data which you are getting for this particular analysis is from retail market. Okay, this retail market, that means I'm talking about Big Bazaar, I'm talking about Pantaloons, I'm talking about Spencer's, I'm talking about Walmart. So it could be any market where actually you are going with some basket, you are filling some items, then you bill and you come out. This is what the process is. So actually I'm talking about this part, that can we do some analysis on this particular basket which you are using during your purchases? The answer is yes. And let me tell you that your baskets are scanned like anything, and that gives a very ultimate informations, or you can say knowledge, which actually is responsible for managing the entire retail market. As far as management is concerned, it is actually manages inventory, It also manages demands. It also manages self-management. And lot more decisions you can take out of this. Okay. The question is how. So let me tell you, before going for a technical discussion of this, let me tell you one thing, what you are doing. What you are doing while going to this market is that you are going with a list which is prepared at your home, and you are going to this market. Once you enter the market, you take a basket and you just start filling items based on your list, and then you go for billing and you come out. So once you come out, you actually get a bill. We call it as transaction. Okay, I'm just relating what you are doing with the technical term. So whatever bill you have is referred as transactions. Okay. So I'm taking Big Bazaar sort of things. So one customer, my one transaction. Second customer comes, transaction 2 comes. Third customer's transaction 3, and so on it is going. Okay. So what you have in this case is excuse me. Because I am having some technical problem, just let me resolve it. Okay. Sorry, there was some technical glitch on my system. So I'm just resuming it. So what we have is that suppose, so the Big Bazaar might be having 500 customers in a day. So there will be a 500 transactions. So there will be a transaction ID. So what you have is this, that you have transactional ID. So it could be any number or combination of characters and numbers. And then you have some set of items you have purchased. So you are start listing with that customer 1, say T100 is there, and having this list of items. Okay. So once you store this, then such databases is known as transactional database. Okay. Transactional database. So we call it a transactional database. So these transactional databases created, I think, out of your purchases itself, and then the domain holder like Big Bazaar wants to analyze these transactions so that they can actually do some sort of improvement in terms of inventory, demands, and self-management as well, and can take some decisions out of it. So this is what the goal is. Now the question is, what sort of improvement they will get? So suppose that out of 500 transactions, we get some sort of idea that some item A, suppose bread and butter. So they found that 90% customers are going for bread and also going for butter. So we found that there is a strong association between bread and butter. strong association. Obviously, such strong associations will be found by applying some sort of algorithms on the transactional data. So we'll talk about that thing also. So once you do that, so how it can help in inventory and all? Certainly, if this is the case, then obviously I can increase the inventory for bread and butter because 90% customers are taking it. If I go for self, then I may be interested to put bread and butter together so that even if you are not interested to have butter, if you go for bread, then there is a high probability that you'll pick the butter also. That means you don't have the butter in your list, but still since you saw this butter beside this bread, you pick it. This is what happening. There is another thing is that you keep bread here and butter in another corner. So you get the bread and you are supposed to take butter as well. Then you actually walk down to this particular corner. So in the meantime, when you saw some other items are kept with some sort of discount, you pick some of the items which is not in your list. So that sort of profit the Big Bazaar might be experiencing it by applying this bread butter to be kept in two different corners. So such decision making, such applications could be a prominent one out of this market basket analysis. Okay. So this is what we are doing, and you can, let me tell you that they are scanning your basket like anything, even that much they are scanning your basket that you itself are not scanning that. Okay. So believe me that when you are roaming around the Big Bazaar or such retail market, that you will realize now that you and your data is analyzed there and there itself. Okay. So that is what we call it as market basket analysis. Then let me tell you one thing is that this market basket analysis is not restricted to this particular retail market itself. This market basket analysis is extended or transformed or mapped to some other domain as well. Like, for example, I can say that baskets could be documents and items could be words. And then obviously I can go for, you can say words associations mining. Okay. So you can see that words appearing frequently together in documents may represent phrases or linked concepts. Okay. So I'm interested to have such thing also. This market basket analysis is widely used in bioinformatics as well. You know that they are having some sort of protein sequencing and all. I'm not well versed of this protein sequencing and all, but since I discussed with some of my peers, so they are actually looking for some sort of association between, you can say, protein sequence and all, and they actually take some decisions out of it. So this is also used in that particular field as well. So this is used in so many fields. Only the thing is you have to map this particular domain into a particular domain which you are looking for. Okay. So if you see that use mainly retail markets and it assists in marketing, it assists in self-management, inventory control, and many. So as far as other applications, it is used nowadays in telecommunication network, traffic analysis, document analysis, bioinformatics, or computational chemistry as well. So the components of this particular market basket analysis is that we look for transactional database, we look for item sets and frequent item sets, and then there are two main components is support and confidence we look for. Okay. So these are types of association rules we look for. You can see that as far as types of association rule is concerned, we can have a Boolean and quantitative association rules. You can see that if I'm saying that there is a bread having a strong association with butter, then we always look for presence or absence of these associations. Whereas, absence of this particular bread and butter. Whereas if you look on this, then you'll find that I'm talking about that a person X having age between this, the same person X is having income between this, is having a strong association that the same person can go for buying the projection TV. Okay, so I can have such associations as well. Okay, so this is known as multi-dimensional association, where actually you can see that there are 3 dimensions used: age, income, and buys. Okay, so that is done. So and when I say that person X is buying bread and the same person can go for butter, so in this case only single dimension is used, that buys in both the sides. So this is referred as single dimensions, whereas this is referred as multi-dimensions association rules. And let me tell you one thing, that I can have multiple on this side and I can have multiple on this side as well. So multiple features or dimensions could be the part of the left side, and multiple dimensions could be the part of the right side as well, is possible. Okay, so that is something you can do. Obviously, the joining of these dimensions could always be done with logical operators like and, or something like that. Okay. Two components, important components to be used for this is referred as support and confidence. As I told you that a rule must have some minimum user specified confidence, whereas a rule must have some minimum user specified support. Okay, so for example, if you see that if I say that 1 and 2 is having a strong association with 3, has 90% confidence, if when a customer bought 1 and 2, in 90% cases the customer also bought 3. Okay? Whereas in this case should hold in some minimum percentage of transactions to have business values. So that means all 3 should appear in some minimum number of percentage. Okay? So that is what we deal with that. Let me tell you one example. So when I say the components, so I have I, which is set of all items. We have D, that is transactional database. So this is what we have is. So you have transactional ID and you have items, and this is my transactional database. Okay. So if this is, suppose A and B are 2 items, 2 items or 2 dimensions, then we can have association between A and B. Then we look for that what is the probability of occurrence of A union B together. Whereas when I talk about confidence, then it's a conditional probability that having A, what is the probability of occurrence of B, that will give you this. Okay. Always remember that when I say A union B, that means in this case, don't be confused with set theory A union B. I'm talking about A union B means A and B. Okay. So for example, if you look, this is my transactional database. This is 4 transactions. These are the items. Now, if I look for this, 1 is strongly associated with 3, then this 1, 3 is having 50% support and 66% confidence. How? I can tell you. 1, 3 is appearing, 1, 3 is appearing in 1, then in 2. So out of 4, it is appearing in 2. So it is 50% support. Okay. Now the question is, what is confidence? So it is conditional probability that 1 is given, and what is the probability of 3? So 1 is given in the, 1 is in 3 transactions, and out of 3 transactions, 2 transaction is having this 3. So this is the probability is 2 by 3, which is nothing but 66%. So this way you can actually decide this support and confidence, and always remember these 2 are user defined, or domain holders can decide this particular support and confidence, because that varies depending upon what items actually you are looking for. So if it is words out of documents, certainly the support and confidence would be different. If it is the food items of Big Bazaar, it could be different support and confidence. If it is electronics item of some big bazaar, then it could be have different support and confidence. Because if I say that bread and butter is having 70% support and 90% confidence, that cannot be with TV or fridge, because you know that these are highly costly items. So the support cannot be achieved with this 70% or 90%. I may be interested to have 30% or say even 50% of confidence. That could actually be good enough for the profitability. Okay. So as far as association rules concerned, it is a simple two steps involved. Is that first of all find all frequent item sets, and then second is generate all strong association rules based on minimum support and minimum confidence. So this first part is only minimum support is involved, whereas second part both is to be considered. Okay, let me give you some example. As far as algorithms, we have algorithms like a priori, which is actually very important algorithm. Then there is some variations of a priori. So these are variations of the a priori, whereas sampling, partitioning, hash-based transition reductions, and there are so many variations are there. There are variations which talks about utility and all. Okay, so that is there in place. So I'm just moving to the algorithm part. Two properties it holds. One is a priority property, the other one is anti-monotone property. A priority property says that if all non-empty subsets of Fi must also be frequent, whereas anti-monotone property says if a set cannot pass a test, all its supersets will fail the test as well. This is something that when I say that AB is frequent, then A and B individually can also be frequent. So this is a priority properties, and it says that if AB fails, then obviously A, B, C also fails, because ABC contains AB also. So this is what anti-monotone property talks about. Okay. This is let me give you some sort of idea that what is happening. So this is your translational database. Now I am fixing the support as 50%. When I say 50%, then that means out of 4 transactions, the appearance of the items into 2 transactions will actually give you 50% of support. So if it appears in 2 transactions and more than 2 transactions, it will actually have a support with 50% or more. So scanning D, then you can see that there are 5 distinct items are involved, and then frequency is 1 is having 2, 2 is having 3, 3 is having 3, whereas 4 is having 1 and 5 is having 3. So if such is there, then obviously I am ignoring 4 because that does not having the minimum support of 50%, and rest will be referred transferred to the first level of frequent item sets, that is known as L1. So this particular first set which you have created based on frequency is referred as candidate set C1, and the other one is referred as frequent item sets L1. Then we make pairs of the 2 items, then we get the second candidate set as C2, then we go for frequencies, then we get this particular frequencies, then again 1 and 2 and 1 and 5 will be ignored, as this is not having the minimum support criteria. So what we get as candidate set 2 is actually this one is L2, which is 1 3 2 3 2 5 and 3 5. Now next is we'll be going for 3 you can say the combination of the items. So I'll be getting 2 3 5, which is having the frequency as 2. So only this is there. Since only one combination is available in case of 3, So your algorithm stops here because there is no possibility of making the combination of 4 items because there is no multiple uh, combinations available in L3. So your algorithm stops here. So that means the algorithm criteria for stopping the algorithm is that there is no further investigation is required, or there is no more common, like you can say higher level of combination is possible, then you can stop the algorithm. So if you look on the property part, you can see that suppose your L3 is having some, one example I'm taking, that L3 is having some ABC, ABD, ACD, ACE and BCD. Then obviously L4 is created out of the self join of L3. Then ABCD you might generate and ACD you might generate because out of ABC and ABD you can generate this, out of ACD and ACE you can generate this. Now the question is, could be possible to include this into C4? The answer is yes, it may be, it may not be. Why? Because C4 might contain ABCD but might not contain ACD. The reason is very simple, that this AD is not in L3. So it actually violates the anti-monotone property of the a priori. So for going, you can apply this pruning stage before generating this candidate set 4. So these properties can be used at any instance to have some sort of optimizations. Okay. For generating association rules, uh, this is one which is responsible for, which actually you can see that we are taking account of support and confidence in this case. So it says that for each FIL, generate all non-empty subsets of L. So suppose for each non-empty subset S of L. So suppose what you have is 2, 3, 5. This is my L. Now I can say that, okay, S is 2, 3. So this particular association rules means 2, 3, which is S, is having a strong relation with L minus S, which is nothing but 5. So how it is? So I can always go for support count of 2, 3, 5 by support count of S, which is 2, 3, which must be net greater than the confidence. Say it could be 70% or something like that. So once if this particular condition holds, then this particular association might be accepted or rejected accordingly. For example, you can see that out of this 2, 3, 5 having confidence of 100%, 3, 5 this is 100%, 2, 5 with 3 is 66%. Suppose if you fix 90% confidence to be accepted, then this need to be accepted, whereas this need to be rejected in that case. So these patterns are interesting patterns, whereas these two patterns are not interesting for us. So that is actually some sort of. So this is how you can actually generate the association rules out of the transactional data. There are some variations, as I told you. So I'm just giving since I'm running sort of time, I'm just giving the quick review of this particular algorithm. Sampling algorithm, as it name itself suggests, that it is based on samples. Okay, that means when I say that D, the reason is why I'm using sampling algorithm, due to the some sort of inefficiency of a priori in terms of large data. As you have seen that uh, uh, in each case where actually you are generating candidate sets, each candidate sets actually requires this database scan. So suppose if your data is of 10 GB, your RAM is of 2 GB, then one candidate generation requires 5 input outputs, because which is nothing but 10 by 2. So each candidates require 10 input outputs of the data, or 10 block reading of the data. And similarly, if you go for this, then it will actually go for 5 into k input outputs. So in terms of large data set, a priori actually introduces high complexity, and it becomes sometimes not efficient as well. So to have efficiency in place, then we can actually go for some sort of optimizations, and we can apply some sampling algorithm in that. What is that is? That is, out of D, I can go for small samples like S1 and S2. Maybe 1 or 2 samples I can consider, and I can apply a priori on these samples, and then obviously check the association rules out of the entire database, and we can say that whatever I got it is actually more efficient than simple a priori in terms of complexity, and it represents the association rules which actually deals with the entire data set. But the reason is, since you are working with samples, there is always the case that you may miss some of the association rules, which is actually present in the data set. But since you are working on samples, you are missing it. So to grab or to actually update that part, what we do is that we make use of negative border functions. Okay. What does this means is, what you are saying is, just I'm giving you the example. Suppose your I is this, you have applied transitional data, and out of D you got some sort of sample 1. Now after applying a priori on sample 1, you get this potentially large data. See, before we call it as large data sets, now I am saying potentially large because it is based on samples. So it is giving you that A, C, D and CD are most frequent. So can we have some sort of recovery of missing association or not? So what I'll do is that I'll consider these potentially large items, and then I'm applying the properties of the a priori, and then I'll be going for NP border functions. What is NP border function is this. This is present in potentially large item sets. Since A and C are frequent, then as far as a priori property is concerned, then AC is frequent, and similarly A and D is frequent, so AD could be also frequent. So there is a possibility that AC and AD could be frequent. So negative border function generates AC and AD as extra frequent pairs. Okay. So that may be included with PL, and that becomes your L in first stage. Since now in next stage we'll be having these 3 and can be joined with, you can say that ACD might be frequent as well, since AC, AD and CD become frequent. So this is again the part of negative border function. So with negative border functions applications, we are having these and this in place. Okay. So now considering this potentially large item PL, and this is the items of the negative border functions. So your L will be PL union negative border functions. So that is actually done to have all possible associations which could be possible. So sampling actually exploits a priori in a very efficient manner, and it reduces complexity significantly, and it also generates association rules, which is good for the data as well. Next is partitioning. I think partitioning is very simple, that you partition the data into n parts, and you are going for applying the a priori in one go. The only the thing is, in case of even sampling and partitioning, if you are going for D1 or if you are going for S1 sampling, this need to be equivalent to the RAM size. So RAM size means memory size it should be. The reason is very simple, that what I want is that I can process the a priori in one go. So it should be equivalent to the memory size. So that is what we do. So with this partitioning also, what we do is that we apply a priori in each partitions, and then whatever large item sets you are getting, you are taking the union of, say, L1 union L2 union LK. LK you go for, and that will give you the large item sets for entire data sets, and then you can check with the confidence. Okay, so that is what we have. There are some, I'll take 1 or 2 minutes. There are some observations out of this market basket analysis is that you can see that there may be multi-level associations that you could be having, like suppose you are saying that milk and bread is having strong associations. You know that milk is having a different category as skimmed or 2% milk. Bread is having white and wheat bread. There may be 2% is having another set of, some set of companies are producing this 2% milk also. So once I can go for some association between these two also, or I can go for some association between these two also, depending upon your requirement. So you can see that, or I can go for association between these two also. So I can go for multi-levels, I can go for uniform support and confidence, or I can go for reduced confidence and support as well. You can see that I'm considering 20/60 for this, whereas if I am going down to the labels, I am going for 6% and 50% also. So in some cases you can go for uniform also. The moment you go for uniform, then obviously when you go for reducing the support and confidence, certainly if you are too high, then we may miss some sort of low level associations. If you are going for too low, then we can generate too many high level associations in that case. So you have to take the decisions accordingly. So I'm just leaving this part. As far as association rules concerned, you can actually generate association rules with numeric attributes, with implicit ordering. All these are possible in your association rules. This is the last slide from my talk. This is some observations which could be possible out of the market basket analysis. You can perform some sort of clustering of association rules as well. There is a possibility that support and confidence in some cases might not be sufficient for association rule generations. Then I can make use of lift, which is actually talks about some correlation between the items. So it is actually giving you one boost to the support and confidence matrix. This is the details you can always go for. There is a case of vertical transactional database, and there is a case of utility mining. Just give me 2-3 minutes. I'll explain each of these. The first is clustering of association rule says that I can tell you one thing is that suppose you are talking about 2 dimensions. Say suppose you are talking about income and you are talking about age. Okay. Now I am having 4 associations which talks about that age, this, and income, this is having buying some sort of thing. So I can say that 30 to 40, say 50 to 60. Then second association says that 40 to 50. Then income is again 50 to 60. Okay. Then third association is 30 to 40, and income is again 50 to 60. Sorry, 60 to 70. Okay. Now fourth is age is 40 to 50, and income is 60 to 70. Now these are the 4 association rules which you have generated. Now the question is, these are 4 distinct association rules because in first cases, you are talking about age 30 to 40, and then income is 50 to 60, then another is 40, 50, then 50 to 60 in terms of income, then 30, 40, 60, 70, and 40, 50, then 60, 70. So this is what we have. Now, if you go for some sort of grid creations, so what you have is, suppose you are talking about 20, 30, 40, 50, 60. This is age. Now, this is income. So say 40, 50, 60, maybe this is 70. So the first is age 30, 40. So this is 30, 40. And income is 50, 60. So you, sorry. So this is what we have. Okay. The second says 50, 60 and age is this. So this you have. The third is actually this. Fourth is actually this. So if you see this grid, you'll find that this is very uniform and this is this. So I can merge these two and I can have age as that 30 to 50 and income is 50 to 70 and can go for buying something. So these four can be merged into this. This is known as clustering of association rules. Okay. The next lift, as I told you, that we make use of correlation to have another metric apart from support and confidence. Vertical trend transfer database, what we have is we have transaction ID and then items. This is horizontal database. This is transactional horizontal database. Now, making it vertical, what I'll do is that I'll make items as transaction ID and transaction ID as items. So I'll be saying that item 1 having transaction ID 100, transaction ID 202 or something like this. So when you transform this into this is known as vertical transactional database. Okay. So sometimes we are interested to mine such databases instead of horizontal because that gives me another you can say way of pattern, looking on the patterns. So that is what we have in vertical transfer database. The last one is utility mining, which is till now we have not discussed anything that we have transaction ID and we have items. So we have transaction 100. I said that bread, I say that butter. But nowhere I have mentioned that a person has taken 2 bread or 3 butters. So when the moment I talk about 2 bread and 3 butters, then your analysis becomes different and your outcomes will also be different. So when we talk about such data to be used for mining, that becomes utility mining as well. One example of utility mining. So the a priori could be altered in some way which can cater this particular information in the data analysis and could be very important. And nowadays, I think utility mining is also very important area of research. We will have done a lot of things in this area as well. So as far as research concerned, certainly utility mining and the metrics, or you can say the any statistical measures which could be helpful for the accuracy and efficiency of the association rules, or you can say market basket analysis could be possible, could be prominent research in this area. So this is my email ID. I acknowledge all the authors and websites whose contents was part of my lectures. Thank you. If you have any questions, please let me know.